Does the rate of kindergarten immunization exemptions correlate to the incidence of pertussis outbreaks in California? For this project, we sought to visualize a correlation by using Holoviews, Geoviews, and other libraries. Two datasets were used: a Kaggle dataset consisting of kindergarten immunization rates in California by school and the associated geographic data for those schools. Second, county-level data summarizing the yearly incidence counts for 70 diseases. And so the inspiration for this project came from two places: the Kaggle challenge related to the data set I just mentioned, and the award-winning Wall Street Journal visualization, which plotted yearly incidence rates for different diseases by state. For many diseases, like measles here, a clear correlation existed between a decline in rates and when the vaccination was introduced. The workflow used for this project consisted of ETL and Dask, or pandas, followed by visualization in Holoviews and Geoviews with a bokeh backend. Data Shader was also implemented via Holoviews, and everything was coded within a Jupyter Python environment. I chose Holoviews and Geoviews because I wanted to leverage their integration with many of the scientific Python libraries, such as pandas and NumPy, but also because of their potential for supporting big data. They're scalable in that they can handle data existing in memory, but also data that has been parallelized, and that's through Dask. Dask is a computational library that enables pandas and NumPy-like computations on parallelized data. So Dask has Hadoop and Parquet APIs. Also, Holoviews and Geoviews implement bokeh and integrate with bokeh and data shader. So that enables really nice interactive visualizations to be built on big data. And finally, it's really user-friendly. Every visualization is considered an element, so you essentially push your data frame or your data structure into an element and modify the element parameters. It's really super simple and easy to use, and it's all integrated into the SciPy stack, so you can do data visualization and data analysis pretty quickly in Jupyter. And so for this, I created 4 separate Jupyter notebooks and built 8 different visualizations. 3 of them were to explore the data, so 2 to explore the county incidence rate data, and 1 to explore the kindergarten exemption data. And then 1 was dedicated just for trying to visualize a correlation between the 2 types. So now let's go look at the Jupyter notebooks. So the first one we're going to look at is exploring the yearly county disease incidence rates. We're going to do this live. What could go wrong? So we import our libraries here, and if I do a step in one notebook, I will gloss over it in subsequent notebooks just in the interest of time. So you load your libraries, and we see the data shader and bokeh logos, so we are good to go here. And now we're loading the infectious disease incidence rates that we downloaded from the California Health and Human Services Open Data Portal, and use the info method to look at the columns and see what type of data we have here, and just looking at a few lines of it. We see we have per county and year, the female, male, and overall count of incidences for this disease, amoebiasis, and then our population and the rate. And the data dictionary describes more in detail what these columns mean. And so we use that along with our own analysis to identify more details about these columns when we use them. So 15 years of data, 70 diseases, 59 counties. And so given this information, we can prune our data to have just the information we want. So only data related to pertussis that is stable as per the definition in the dictionary, and across both genders. And we still have 15 years of data, and the data still looks good by printing out some lines. So now we can start visualizing. For this visualization, I adapted the Holoviews example that was also inspired by the Wall Street Journal visualization. So this is going to be a heat map in time across all the counties. So we create our data frame, just pruning the existing data frame that we've been chewing on. And then here's where the user friendliness of Holoviews will be obvious. So we're creating a heat map element, setting the options for it, so the size of the visualization, the bokeh tools that we want to use, and here we're setting the dictionary that will pass to the element and visualize it. Ta-da! And so here we have per county, and for each year we have the incidence rates represented as a color. So the warmer colors being higher incidence rates, and as our hover tool is telling us, the cooler ones having lower rates, so in this case 0. And so two obvious trends that I see right now is that we can probably disregard any data from this data set for pertussis before 2010 because there must have been a lack of data, or maybe there really was a rate of 0, I'm not sure, but it's probably not pertinent. And then this other, we see a spike right here, 2014, this spike of warmth here, indicating that the rates are high for pertussis across the whole state. So that's interesting. Okay, now we have counties here and a state, so let's try to also visualize this geographically. And so we can just use our same data frame, and in this case we're going to use a different element. This is all just grooming and data grooming in pandas. Our example here that we're going to use is the Texas chloroplath example from the Holoviews examples, and we're adapting that for our use case. And so we groom our data to fit this, and more grooming up here. Here we use the Holoviews polygon, pass it our, in this case we're passing it a dictionary rather than a data frame, indicating what our key values are here and what the values are. We want a hover tool, set some style, and pretty quickly we have a very nice view, a chloroplath of the rates. And this is just for one slice. Another powerful use in Holoviews is the interactive visualizations that are in the apps, the bokeh apps that are available, because bokeh is in the back end. So why don't we view this in time, see if there's any patterns that emerge. So what we're going to do is we're going to take this code that we created here and functionalize it so that we can pass streams of data into it, and essentially pass in the year to this function, this chloroplath function, and have a new Holoviews element be created. So do it live again. Import, manipulate our data frame in here. So this get by year, we functionalize that same function we had in the earlier notebook. Oh, I should mention that we have adapted code for this app from the Gapminder example. Get by year, and then using these streams, the year is streamed into our function, and then new visualization is a new element is created and displayed in our app. So here, this is kind of the guts of the app where there's animations and there are buttons. And finally here at the bottom, you see there's this doc that's passed around, and that's the document with your visualization in it. And we can attach it to our notebook here with this line. And so we run this code, and then we have this nice bouquet app based on our data. So we can cycle through the years and see how the incidence rate changes over time. And if you want to go crazy, you can hit the play button and let it go. It doesn't appear to me that there's really anything obvious other than that spike. 2013, 2014, there's a huge spike. And now, so we've looked at the incidence rate. Let's look at the kindergarten information. So we have the kindergarten data, and here what I really wanted to highlight was that we can, okay, so this is loading in the student data, the geo data. We're going to enrich the student data with the geographic information. So here is the school code, and these are the exemptions here. This number representing personal belief exemptions, and then personal medical exemptions. I'm just going to breeze through this so we have time to look at the exemptions. And here's the interesting part. We're loading our data into a DASC data frame. And so again, this is very almost transparent to the user what's on the back end of your data when you're making these visualizations, because we could have a DASC data frame that's reading from Hadoop, for example. And so here we are creating points. And so those are these individual schools and plotted for ones that have exemptions. And then using the datasheet library, Holoviews is able to rasterize and build a similar view. But when you zoom in and out of these visualizations, you can see that the structure is maintained and that we don't get blobs of points here. And that really was the point of this. If we wanted to look at the school exemption rates in time, we can build another visualization here. Here we're building scatter plot again, some points. But now we're going to use this overlay function to be able to apply tiles, map tiles. So then we get a map with the points on top of it. And so the size is indicating the total number of exemptions. And since this isn't adjusted for population, I don't know that this gives us too much insight other than it increases, the total number of exemptions increases, but it's not certain how that relates to the population, whether the population increases also. And so finally, we're going to plot the two data sets together now that we've explored them. And again, a lot of the manipulation in pandas is going to be joining the two data sets. So I'm just going to breeze through those. Okay, so now we've created our data frame that combines the school data with the incidence data. And so now we're going to, using the Gapminder example again, we're going to build an interactive scatter plot to show the relationship between the waiver rate and the incidence rates. And so in time, it really isn't very clear here that there is any, let's go, there we go. It just kind of looks like a general increase overall. We see low waiver exemption rates, but high incidence rates. You see high super high waiver rates over here, but low incidence rates, so this wasn't very useful or obvious. And also I just wanted to point out again, we use this overlay. This is an element, the scatter plot element, and this is the text here, so like the year changing. Okay, so let's build a few more. We built the scatter plot, let's build the scatter plot geographically again. So here, this is the same example we saw in the 2-minute video, where the size of the point is the exemption rate. So here we are increasing years, and the color would be the incidence rate. So I would have expected, just naively, that the large bubbles would also have a warmer color or a high incident rate, but that wasn't the case. There's a smaller one that's has a higher incidence rate than the big one. Okay, so let's continue investigation. More here. We have more data manipulation here, and then now we're doing a heat map again. Let's see this in time. In this visualization, it's difficult to see what the relationship is, like prior relationship between a high exemption rate and a incident rate. So we visualize those using the same heat map, and again, nothing very clear. And here, Los Angeles has a very, very high, if not the highest, exemption rate, yet it doesn't have the highest exemption rate highest incidence rate. And so finally, if we look at the general trend of these incidence rates, again, using now the plus operator to put both of the graphs together, it appears that there is a minor increase. Here's the increase in the rate per county, the exemption rates. That spike in 2013, which is the year before the big trend here we see, where there's a spike in pertussis incidence in California. So maybe a correlation. I'm not an epidemiologist, and this is very sparse data and only a few years. So as part of the lessons learned, we definitely need more data and probably more features to investigate this correlation. But I hope you saw in this demo that Holoviews and Geoviews are very powerful and flexible and really easy to use. So I hope you will give them a try. Thank you.